probability. If you think that probability means you're reduced to guessing, the casinos of Las Vegas are ready to prove you wrong. Try your hand at any one of these games of chance, and you can see the power of probability. Let's say I place a $20 bet on number 29 here at the roulette table. The house doesn't know whether I'll win on this spin, or the next, or the next.
1.
But it does know the probability that I'll win. In this game, it's 1 in 38.
21. 29.
So even though I may win now and then, in the long run, the house always takes in more than it loses. The point is, the house doesn't have to know the outcome of any single card game, roll of the dice, or spin of the roulette wheel. Casinos can still be confident that over the course of thousands of spins, deals, and rolls, they will win. And they can predict with exquisite accuracy exactly how often. According to quantum mechanics, the world itself is a game of chance, much like this. All the matter in the universe is made of atoms and subatomic particles that are ruled by probability, not certainty.
At base, nature is described by an inherently probabilistic theory. And that is highly counterintuitive and something which many people would find difficulty accepting.
One person who found it difficult was Einstein. Einstein could not believe that the fundamental nature of reality at the deepest level was determined by chance.
And this is what Einstein could not accept. Einstein said, God does not throw dice. He didn't like the idea that we couldn't with certainty say this happens or that happens.
But a lot of other physicists weren't so put off by probability, because the equations of quantum mechanics gave them the power to predict the behavior of groups of atoms and tiny particles with astounding precision. Before long, that power would lead to some very big inventions. Lasers, transistors, the integrated circuit, the entire field of electronics.
If quantum mechanics suddenly went on strike, every single machine that we have in the US almost would stop functioning.
The equations of quantum mechanics would help engineers design microscopic switches that direct the flow of tiny electrons and control virtually every one of today's computers, digital cameras, and telephones.
All the devices that we live on, diodes, transistors, just form the basis of information technology, the basis of daily life in all sorts of ways. They work, and why do they work? They work because of quantum mechanics.
I'm tempted to say that without quantum mechanics, we'd be back in the dark ages. I guess more accurately, without quantum mechanics, we'd be back in the 19th century. Steam engines, telegraph signals.
Quantum mechanics is the most successful theory that we physicists have ever discovered. And yet we're still arguing about what it means, what it tells us about the nature of reality.
In spite of all its triumphs, quantum mechanics remains deeply mysterious. It makes all this stuff run, but we still haven't answered basic questions raised by Albert Einstein all the way back in the 1920s and 30s. Questions involving probability and measurement, the act of observation.